Welcome to the deep dive. So look, if you are building anything serious in the cloud, or maybe you're prepping for your architect certification, or if you just want the shortcut to really understanding cloud security at its foundation, then this is the deep dive for you. Today, we are opening the vault on what is probably the most critical piece of AWS security, identity and access management.
Right. We're synthesizing the core concepts of IAM, which is really the engine room. It grants, it restricts, it audits every single action inside your AWS environment. Our mission today is to move beyond just definitions. We want to explain how these pieces all fit together to build a secure architecture, really targeting, domain 1.1 of the solutions architect objectives.
I always think of it as like we're setting the rules for the digital security zones of the cloud. It's not just about who gets the key to the main door. It's about making sure that key only opens one specific locker for a specific amount of time and under constant watch. We're defining trust.
Trust relationships. That is absolutely the right way to frame it. And the very first trust relationship you have to define is the one between you and Amazon, which is why we have to start with the non-negotiable foundation, the shared responsibility model.
Okay, so before you even configure a single thing, you have to know where your job ends and where AWS's job begins.
Exactly. AWS is completely responsible for security of the cloud. So this is everything below the hypervisor. We're talking to physical data centers, cooling, the hardware, the virtualization software itself. That's Amazon's duty. They own that burden.
But the second you spin up a resource, say an EC2 instance or an S3 bucket, the ball is suddenly back in your court.
It is. Yeah. That's security in the cloud, and it is 100% the customer's burden. This means patching your operating systems, encrypting your data, and most critically for us today, managing your identity and access management setup.
What's a good example of that split?
S3 is the classic one. AWS provides this incredibly secure, durable service. That's security of the cloud. But if you go in and configure a bucket policy that accidentally makes all your customer data public, well, that's a configuration failure in the cloud. That's entirely on you.
And that's why architects have to be configuration experts, because one wrong setting can completely undermine all that foundational security AWS gives you. It's like being handed a fortress, but you forgot to lock the treasury door inside.
That responsibility forces us then toward the core architectural philosophy that has to govern every single access decision we make. And that is the principle of least privilege.
Right. We all know the definition. Give a user or a service the absolute bare minimum permissions they need to do their job and nothing more. But where's the real world difficulty in actually doing that? It sounds so simple.
The difficulty isn't in the definition, you're right. It's in the implementation when you're under pressure. When you have a deadline, it is so much faster to just assign a broad, pre-built AWS policy like power user access than it is to sit down and carefully write out the 5 specific actions the developer actually needs.
That temptation for speed.
That efficiency choice is the enemy of security.
So how do we fight that? How does an architect fight the impulse to just over-permission everything and move on?
Well, you use the tools built right into IAM for this. If you're trying to figure out a policy, you should be using the policy simulator. It lets you test changes before you deploy them. It shows you exactly what actions and identity can and cannot perform on a resource. It takes out all the guesswork.
And guesswork is what leads to allow on everything, which is, that's the nightmare scenario.
It is. And the other tool you have to use is the Access Advisor. This tells you when a user or a role last accessed a specific service. So if your database role hasn't touched any IAM service actions in 6 months, you can safely remove those permissions. It helps you continually trim the fat.
Okay, let's nail this down with a scenario. We have a junior developer. They need to upload a daily report to one specific folder in one specific S3 bucket. That's it.
Right. We do not give them administrator access. We don't even give them S3 full access. We scope the policy precisely. Allow the action S3.put object on the resource ARN that points only to that one folder path inside that one bucket, and deny everything else. That level of specificity is what separates a secure architecture from a reckless one.
Right. Okay, so let's unpack the building blocks we use to actually enforce this stuff. We're talking users, groups, and I think most critically, roles. Let's start with the basics. Users and groups.
Sure. Users are your long-term identities. They represent a person or maybe an application like a CI/CD system. Groups are just They're containers. They're a convenience. If you have 50 data scientists, you apply one policy to the data scientists group, not to 50 individual users.
Okay, but doesn't grouping users sort of work against least privilege? I mean, if one person in that group needs one tiny extra permission and you add it to the group policy, then suddenly 49 other people get a permission they don't need.
And that is a fundamental tension in IAM design. You are absolutely right. You're trading management simplicity for security precision. The best practice is to use groups for really broad access categories, things like read-only or console access. But when you need very specific or temporary or highly sensitive access, that is where the power of roles comes in.
Let's get into roles, because this is where the system gets really, really smart. Roles are not people. They're identities you borrow.
Exactly. Think of a role as a temporary access pass. They solve the biggest security nightmare, which is hard-coded, long-term access keys just sitting in a config file somewhere. A role is defined by two key parts, a trust policy and a permissions policy.
Okay, so break those down for us. What's the difference?
The permissions policy is the easy part. It defines what the role is allowed to do. So, for example, read from a DynamoDB table. The trust policy is arguably more important. It defines who is allowed to assume that role. Is it an EC2 instance? Is it a user from a corporate directory? Or is it maybe an identity in a totally different AWS account?
So in my EC2 instance example, the application running on it needs to write logs to S3. I assign an IAM role to that EC2 instance. The trust policy for that role would say that the EC2 service itself is allowed to assume it.
Correct. The EC2 service principal then makes a call to AWS STS, the security token service. STS validates the trust, generates temporary credentials, and hands them to the instance. And here's the critical part. Those credentials automatically expire, usually in an hour or less. When they do, the instance has to re-authenticate to get new ones.
Which means if an attacker gets onto that EC2 instance and steals the credentials, they're only useful for a few minutes, not for years like a hard-coded key would be.
That is the core security mechanism right there. It's the heart of modern cloud security.
And while we're on policies, we should probably touch on the choice between AWS managed policies and inline policies.
Right. Managed policies are the pre-built ones, like Amazon S3 read-only access. They're great for general use. But for high security, you'll want to create your own customer-managed policies. They're reusable, you can version them, it's much cleaner. Inline policies, they're attached directly to one user or one role. When you delete that user, the policy is gone forever. They enforce the tightest possible least privilege, but they become a nightmare to manage at scale. So we generally steer people toward granular customer-managed policies.
Makes sense. Security needs to be organized. Okay, so let's sail this up. We're not in one account anymore. We're in a huge enterprise using AWS organizations with hundreds of accounts.
Yeah.
How on earth do you centralize identity management across that kind of landscape?
Yeah, manual management is it's impossible. The answer is AWS IAM Identity Center. You might still hear it called by its old name, single sign-on. This service becomes your central hub for users and groups. You define access permissions once, and then you can deploy them across all of your member accounts.
So Identity Center handles the user authentication, the who. But what stops an admin in one of those member accounts from doing something that violates company policy, like creating a database without encryption enabled?
That's where you bring in the ultimate guardrails, service control policies, or SCPs. These are attached at the organizational level. They are the Supreme Court of permissions.
How supreme are we talking? Do they really override a local admin?
Absolutely. An SCP defines the maximum allowed actions. If an SCP at the top level explicitly denies the action s3.delete bucket, then no one in that account, not an IAM user, not a role, and not even the root user of that member account can perform that action. An explicit deny at the SCP level is final.
Wait a minute. If the SCP is that powerful, doesn't that create a risk, a different kind of risk? If the big organization provides this fail-safe denial of dangerous actions, doesn't it encourage the local admins to get a bit lazy? To over-permission their users, knowing the SCP will catch the really bad stuff?
That is the critical tension. You've just hit on the most challenging part of architecting security at scale. That reliance on the big safety net can absolutely breed local complacency about least privilege.
So how do you fix that? How do you enforce least privilege inside an account, even with the SCP umbrella?
You introduce another intermediate guardrail, permission boundaries. An SCP sets the maximum for the entire organization. A permission boundary sets the maximum permissions that a single user or role within an account can ever have.
So you have layers.
Exactly. The central security team defines that boundary. So the SCP might say no one can delete a database, The permission boundary inside the developer account might say, no developer can ever have permissions to create new IAM policies.
Hmm.
And then the developer's specific IAM policy gives them just s3.putObject.
So you have 3 layers of restriction.
You're stacking your defenses. The identity policy and the permission boundary must both allow the action, and the SCP must not explicitly deny it. That's how you get governance at scale.
Before we move on, we have to do the required public service announcement. The root user.
The root user. It's the master key to the whole kingdom. The rule is simple and absolute. Use it once to create your first administrative IAM user. Then you lock those root credentials in a secure vault, turn on multi-factor authentication, and you never touch it again for day-to-day stuff. It's just too powerful. It can do things no IAM identity can, like close the entire account.
Okay. So secure the root, set your boundaries, define your SCPs. That's internal. What about external? When a resource needs to grant access to another service or another account.
This is where the difference between policy types really comes into play. So far, we've mostly talked about identity-based policies, the ones you attach to a user or a role, but there are also resource-based policies.
Which you attach directly to the resource, like an S3 bucket policy.
Yeah,
How do those two interact?
it's like a handshake. For a cross-account request to work, the identity in account A needs an identity-based policy that allows the action. And the resource in account B needs a resource-based policy that allows the principal from account A to access it. If either side says no, the whole thing fails.
So that's why if I want another account to access my S3 bucket, I have to update my bucket policy to explicitly allow them, even if they have a policy on their side that says they can access S3, both have to agree.
Correct. And that handshake is fundamental for building secure data perimeters in the cloud.
Last piece, the real world. Big companies already have Active Directory or Okta. They're not going to recreate 50,000 users in AWS. How do they bridge that gap?
They use federation, usually with the SAML 2.0 protocol. This lets them delegate the authentication part. So instead of AWS checking the user's password, their existing identity provider, or IDP, handles it.
So the employee just logs into their normal corporate portal.
Exactly. The IDP authenticates them. Then it generates something called a SAML assertion. It's basically a signed document with info about the user and their corporate groups. That gets sent to AWS.
And what does AWS do with that?
AWS gets the assertion, and it uses the trust policy of an IAM role to validate it. It maps the user's corporate group, say level 3 engineers, to a temporary AWS role, maybe prod deployer. The user assumes that role, gets temporary credentials from STS, and they're in.
It's amazing how it all comes back to the same mechanism. Roles on EC2, federation from outside, it all runs through the security token service, handing out temporary expiring credentials.
It's the secure heartbeat of the whole system. Using STS minimizes the attack surface and gives you that implicit credential rotation.
So, wrapping this up, what does this all mean for the architect designing a system? The architect part isn't just knowing definitions. It's about that balance. You have to define these really robust security boundaries with SCPs and MFA, but you also have to make it usable. People still need to do their jobs without the system being too rigid.
It's a continuous friction point. You're always tuning those knobs of access, making sure security doesn't stop innovation.
Which brings us back to that core tension we talked about. We've established that SCP set the absolute maximum permissions for an account, and least privilege pushes for the absolute minimum at the user level. So here's the thought to leave you with. How do you design your internal governance using things like permission boundaries to make sure that the safety net of a powerful SCP doesn't accidentally hide the fact that your day-to-day identity policies are way too permissive and are violating least privilege every single day? That's the question to mull over as you build your next multi-account platform.